Hello and welcome back to an unexpected video 9 of making schematics and PCBs with KiCad. I hadn't expected to make another KiCad video, but as is always the case, videos are never complete, they just escape. And because of the new version of KiCad, KiCad 6 that has come out, with some of the differences that it has between KiCad 6 and the older version 5 that I filmed the other videos in, and also using the Volterra V1 printer for making our PCBs, just having more issues with through-hole components, through-hole printing. So I decided I'd make this video to highlight the new KiCad 6 and do surface mount boards. This video is made mainly for my high school electronics students. If anybody else is watching it, good luck. Hope that it helps you as a hobbyist. I'll try to include things that would help hobbyists in this video as well. I would highly recommend watching my previous videos, making schematics and PCBs with KiCad. Very worth your time watching those. This video is intended to be a step-by-step first project for my high school students, to teach them how to use KiCad and to introduce them to the Volterra V1 PCB printer using surface mount components. So let's get started. First step is to open KiCad. So go to your desktop and click on the KiCad icon, or open it from the Start menu. You'll notice the layout for KiCad 6 is a little bit different than KiCad 5. The positioning of the workflow icons is a little different than across the top, but it's the same basic elements. We have a schematic editor, the PCB editor are going to be our two main programs that we use, but there's some very useful other programs that they've added. An image converter and a calculator, a drawing sheet editor. There's just a few new tools that are very helpful at times. And the layout, I think, looks cleaner. It's very nice. So in our main KiCad window, we need to start a new project file. So we'll go to the Create New Blank Project, click on that, and then we need to decide where we want to save it. For my students, I've set up a shared drive. We have a KiCad folder in the shared drive. KiCad 6.0 created a user projects folder, and then each student needs to create their own folder with their name under the user projects folder. So we'll go to my folder and then select the title for your project. I decided to go back and redo the same continuity tester, but this time using surface mount components. So we go back to our original schematic for the continuity tester that I used in all the previous KiCad videos. So let's name our file Continuity Tester. So I'm going to name my file SMD for Surface Mount Device Continuity Tester. Okay, when we save that, it creates a folder with all the different files. So first we're given the schematic editor and the PCB editor. So we can now open the schematic editor either by clicking here, or go to the File Open menu, or even open an existing project. The next step is to go to the settings for the paper size and title block info. I always like to do this right at the beginning, so I can copy over the issue date. We can put the title as SMD Continuity Tester. I'd like to put for a comment the author or the designer, so I'll put myself as the author. So once you have what you like in the title block info, click OK, and then notice if we zoom in on that, it has that information. Again, when you're using KiCad, the mouse buttons, you can click the center wheel and drag. If you're using the scroll wheel, you can zoom in or out. It works the same way that way as the previous version of KiCad. So when I look at this schematic, I see the 555 IC. That seems to be the central component, so I'm going to start with that. We'll lay that first on our schematic, and then all the other components around it. Let's go to the KiCad schematic editor and insert a 555 IC symbol. The main tools in KiCad 6 look the same. Some of these icons at the top are in a different order or have changed. Along the right panel is the Add a Symbol, so I'm going to click on that. First time you do that, it loads the libraries. Now I can click anywhere on the schematic and add a symbol. These are large libraries, so sometimes it takes a while to load them, so here we have a little bit of time while this is loading. So we'll just wait patiently, and finally it pops up. Don't worry if it takes a minute or so. The easiest way to find the symbol you want is to type it into the filter. So I'm going to type 555, and here's my different timers. So here we have a LM555, and if I select that, it shows a view of the schematic symbol and a footprint. It also tells me the footprint package. Now this you don't have to worry about right now in the schematic editor, but thinking ahead, since you're going to lay this out on a PCB, it's very helpful if you know what size component, what the footprint is going to look like. The footprint again is the physical layout of this component. So here it says the footprint is a SOIC-8. What that stands for is a small outline or small outline integrated circuit with 8 pins. It even has a data sheet here, so we could go and look at that. I'm going to go ahead and select that component by double clicking on it, then bringing it over anywhere to my sheet, click once and it drops that component in. Now if I click again, it pulls it up again, so I don't want to do that. So once you've dropped the component, you can either right click and then hit cancel, or you can go over to the arrow on the right side and click the select item tool, and so then you're not dropping additional, it's not pulling up an additional window of the add another symbol. Now it's a little small to see, so again if you use the scroll wheel you can zoom in, and there's my 555 IC. If I want to move the symbol to the inside, I can move it where I want. If you left click, it highlights it, then you can just click and hold while dragging that to the inside. Click outside somewhere, it just moves the labeling to the inside of that IC. The next thing I need to add are some resistors. If I look at my original schematic, I have 4 resistors. So let's add 4 resistors. I'm going to zoom in just a little as I add those. I'll go to the add a symbol. This time I'll type in resistor. I'm going to use the symbol for a US resistor symbol. I'll click OK, and on the original schematic it was somewhere over here for resistor 1, so I'll click there and then cancel. Now I could go back to add another symbol, pull up that window again, click the same thing again, but to save time and to help later on down the line, let me show you a little trick that you should use. Since I know there's 4 resistors and I want them all to have the same size footprint on my printed circuit board. So if I go ahead and select the footprint now and then copy this resistor symbol and paste it instead of having to select from the add a symbol menu, it'll copy the footprint data into all the other resistors I add. Now I've only got 4 resistors, it wouldn't take that long, but in some schematics you might have a lot of resistors. So if you learn to put the information into the component first and then copy that, if you have multiple of the same component, it'll save you time down the line. I'll show you now how to add the footprints. That way when you import the schematic over to the PCB layout, it'll already come with those footprints. Double click on your symbol and it has the symbol properties. We're going to change the reference to resistor 1 and give it a value. It was a 1 k ohm resistor, so I'll type 1K. Now when you click in the footprint window, notice this icon looks like books on a shelf. That's your footprint library. So I'm going to click on that and it comes up with a library. In the filter I can type in resistor and it gives me 2 choices. Resistor SMD stands for surface mount device, or resistor THT for through hole technology. Well, we want the SMD. Here's all kinds of resistors that are SMD, but which one should I choose? That depends on where you order it from, what the component actually looks like. So the way I do this, go to your component supplier online. Most components you have to get online anymore, so 2 that are the big suppliers that I use all the time, Mouser and DigiKey. So let's go to Mouser's website. Here it is. And you can create an account and log in, and if you go to account you can log in. You can develop different projects, so you can store all the components under a project menu if you want. But for now, if you just want to type in the part, just type resistor SMD, hit enter, and let's see what it comes up with. And there are lots of kinds of resistors, so if you look at this, it looks like the most components are either thick film resistors, SMD, or thin film resistors. So let's just click on the first one, the thick film resistors. You can narrow down what you want to see by adding some filters here. So I'm going to scroll down and select 1 k ohm resistance as our value, and our power rating, let's say I want a 250 milliwatt, a quarter watt resistor. Then if I hit apply filters, notice how now up at the top it's telling me I'm looking for passive components, resistors, film resistors, thick film resistors, surface mount device, with a power rating of 250 milliwatts, or a quarter of a watt, and a resistance of 1 k ohm. I can click this button to sort the prices by ascending order, so it'll give me the least expensive. But lately, when I've been doing that, because of the supply chain shortages and chip shortages around the world, it's coming up with a lot of parts that are unavailable, temporarily unavailable. So instead, I'm just going to scroll down till I find prices, and notice, here's, a single one. You can buy one for 14 cents, 10 for 12.5 cents a piece. Obviously, the more you buy in bulk, the less expensive they are. So I'm going to scroll down, try to find one that's, reasonable price. Here's one that's 10 cents a piece. I can get 10 of them for 7.6 cents a piece, or 100 of them for 3 cents each. So let's click on this part. It comes up with all the specifications for this part. And if you scroll down through the specifications, what I want to point out to you is the case code information. This is what you need to know to select the right footprint. This says this resistor has a case code of 1206 in inches or 3216 millimeters. If we go back to the KiCad library, we can scroll down and see eventually there is a resistor with 1206 or 3216 metric. That's the one I want. That's the resistor that's going to be the one that's shown here. Now you can find the case code information oftentimes in the specifications, or you can download the data sheet and look through the data sheet to make sure you're getting the right footprint. I go back to my KiCad. If I double click on that, it puts it in the footprint window. Now I've got all my information I need. I can even display the footprints for my parts so I know which ones I've already assigned footprints to. If I click on that, I can move it over so it's out of the way and I can see what I have. So rather than going to add a symbol and repeating the whole thing again, now that I've got resistor 1 with all of its properties, including the right footprint, I can just make sure that my select items arrow is click on resistor 1 and then hit Control C. It will copy that. It's a hotkey to copy. Then anywhere else on the schematic that I want, I can hit Control V and paste. Again, Control V, I can move it to wherever I want it, and then click again on the pad and it pastes it. So Control V and move it to where you want, I can paste. If I look at my original schematic again, it shows resistor 2 on this side, resistor 3, and then resistor 4 coming counterclockwise. A 120K, a 220 ohm, and a 10 ohm. So I'll do that in KiCad. So I go over to resistor right here, I double click on it, change it to resistor 2. The value would be a 120K, and it has the same footprint already selected. So I hit OK. The next resistor is here. Now it's facing a different direction than in my original schematic. I can click it or even hover over it and then hit the letter R on the keyboard. It's a hotkey for rotate, so I can rotate that resistor to however I want. Double click on it, change it to resistor 3. It's a 220 ohm resistor. If I want just my wording to rotate, I can highlight just that and hit the R key and it rotates them. And then the last resistor was a 10 ohm resistor, so double click on that, change it to R4, 10 ohm resistor. Thank you for watching this video so far. We'll take a break and then pick up in the next video, KiCad 10. In this one I taught you how to start KiCad 6 and begin schematic capturing, how to find component footprints from parts suppliers like Mauser or DigiKey. Please watch the next video in making schematics and PCBs with KiCad, where I'll continue explaining how to finish your schematic capture, arrange the symbols, and get everything prepared to export to the PCB editor. Thank you, and please remember to subscribe.